Hello and welcome to Improving Battery Life and Energy Efficiency video. My name is Charu Agrawal and I'm a program manager with Microsoft. In this video, I will be providing an overview and demo of energy efficiency assessment and a walkthrough of the results. Energy efficiency assessment helps you measure, analyze and improve energy efficiency or battery life of your system.
So why did we build it? Battery life is one of the key criteria for evaluating any mobile device quality, but it is not easy to measure the battery life. First of all, there are very limited options in terms of tools to measure battery life. Then most of the tools provide the measurement for the battery life, but not much of diagnostic capabilities. Then most of the existing tools are destructive, leaving the machine in unusable state, which creates a barrier to run the test. Another complaint by PC evaluators is that these tools do not measure the battery life in real-world scenarios, and they are not very flexible either. So to address the above issues, energy efficiency assessment is built. It does not alter the system state and leave the machine as is after execution. The test is very flexible and highly customizable. You can configure at what percentage to start the test and when to end, the execution mode and the workloads. It generates results ranging very high level, which is the duration of battery life, to detailed event trace log files, highlighting energy efficiency issues. We believe using this assessment, OEMs, developers, and end users can measure the battery life easily and consistently at various stages of PC lifecycle. Application developers can identify issues with power consumption in their applications. The assessment will help PC reviewers in better evaluating the battery life, helping users make better informed decisions on selecting the right PC. OEMs can configure their machines for better battery life due to insight into the battery life consumption, whereas application developers can easily identify issues with the way their applications are consuming power. They can also easily test their fixes with this assessment, which is non-destructive, and have several quick run options as well. So how does this assessment work? Configure, execute, and result. Well, configuration is the key to measure battery life for right scenario. Though there are already few pre-configured jobs available in ADK to begin with, but I'll go over few key configuration settings here. First, you can add any number and instances of the workloads from the available list of workloads, which includes idle, streaming media, file, and photo handling. And then you select the execution mode, whether you just want to get battery rundown numbers to compare the battery life of various machines, or just a diagnostic run to investigate power consumption during idle. You can even select battery rundown with diagnostic. You can also define custom battery start and end percentage of conditions. Then it verifies certain system settings which can greatly impact power consumption, like wireless, power plan, and antivirus. And then system is prepared to run energy efficiency test effectively by first executing process idle task, which sometimes can take up to 30 to 40 minutes depending upon your system state. But you do not need to worry about remembering the sequence of these steps, as a wizard will guide you through all these steps. Once all that is done, you will be asked to unplug the machine and it will start the test by executing all the workloads until the end condition is met. The assessment generates two sets of metrics. One is battery consumption related and other is diagnostic related metrics. Battery consumption related metrics showcase battery details like design capacity, remaining capacity, how long it ran for, etc. Whereas diagnostic metrics showcase the key system activities during assessment. If any of these system activities cross a certain threshold, they can impact energy efficiency, and those metrics will surface as an issue to draw your attention. It also generates an ETL or event trace log file recording the key system activities during the assessment that can be analyzed in WPA or Windows Performance Analyzer. You can compare results from different runs across same or different machine. Few words of caution before you start the assessment. Please close any other open applications. During the assessment, do not start any other application or any other assessment job. Once the assessment starts, do not interact with the machine until it finishes, as it can impact the results. So with that, let's go to the live demo. So I have Windows Assessment Console open here. The first job you see here is the battery rundown job. You can click on run and it will start the job in the default configuration. Or if you want to configure the parameters here, you can go to the configure option and it lets you configure the different options. First, you can select the mode, whether you want to run battery rundown, rundown with diagnostic, or just the diagnostic. You can define your start conditions and end conditions. You can add and remove various workloads that you want to run in this assessment with. So for this video, I ran the assessment earlier and collected some results. So let me pull up one of those results. So here are the top level metrics surfaced in the results of this assessment. The first one is the total time the assessment ran, which is 594 seconds. Let's drill down into that. So it tells me here that I ran idle energy workload during the entire lifetime of this assessment. If I go to battery count here, it shows that the test started at 98% and ended at 6%, and during this time how the battery was drained. And then there are various diagnostic related metrics. So if I drill down into the disk idle efficiency issues, I see that there are 72 disk flush metric. There were 72 disk flush incidents, and I see there is a corresponding issue with that. So it says that there were 72 times during idle the disk was flushed, which is too much. And if I click on this link, it will open up the ETL file in the Windows Performance Analyzer for the detailed analysis. So if I look into that file here, and I see that disk usage metrics is displayed here. I see there are a couple of spikes here in the disk usage. I can select a particular segment here and zoom into that, and it gives me a better view, a closer view of that time frame. I can select another view here, and it tells me exactly that which process was calling which module and what was happening during this time. If you still want to drill down deeper, you can select a smaller segment here and drill further down. And it exactly tells you that which IO type was being done by which process and what was the time taken into. We'll have additional videos going over the WPA analysis of all of these issues, but for this video, let's go back to the Windows Assessment Console. So before I wrap up this video, one other view that I want to show you is the comparison view. So I add another set of results here, and that tells you that there were two side-by-side runs. One took 594 minutes, which we talked about, and the other one was 396 minutes. And if I look into that, I see that the first one was using idle and the second one was using streaming media, which kind of explains the difference in the numbers, as streaming media is more resource intensive, so that will have the battery drain faster than the idle. You can go back, you can go into the various metrics here and compare the different issues.
Here is a list of related sessions that can help you better understand Assessment and Deployment Kit, Windows Performance Toolkit, and few other assessments. Thank you very much.